All right, hello. So now what we have to discuss is what are we going to do when we have complex eigenvalues in our system. But before we go into there, we have to discuss some properties about complex numbers as for a preparation for that lesson. Okay. All right. Now we know we are going to have complex numbers as our eigenvalues. But also there is one more thing. Our eigenvectors is also going to be complex. That means look at this vector. So all the terms in this vector are complex numbers. Okay, so it's a complex vector. All right. So one of the things that one of the skills that we need is we should be able to decompose an eigenvector or an complex vector into its real part and complex part. So specifically, we give a new notation b1 plus ib2. Now, what does that mean? So, b1 means the real part of the eigenvector. b2 is the complex part of the eigenvector. Now, b1 and b2 are vectors themselves. Okay. So, let's see how are we going to do that. What you're going to do is to create b1 for this example. Look at each row and extract the real part of the complex number in each row. So here in the first row, what is the real part? The real part is 2, right? So 2 here. What is the real part in the second row? 1. So this is b1 plus I times. Now extract the imaginary part. Now here always we have plus in the middle. So this b2 in fact contains signs. Okay. So for example here 3 is the coefficient of the I, and here the coefficient of the I is -2. So b2 is 3 -2. Okay. All right. It's a little bit different from beta in a complex number. Okay. All right. So let's look at several examples quickly. So here b1 is going to be, now to extract the real parts, -1 here, 3 here, and capital B2 are the coefficients of I. So here 2 in the first row, here in the second row -4. So see, I take it with the sign. All right. So several important examples. Now here's a special example. You have 2i. What is the real part? 0, right? There's no real part. What is the real part here? 1. So b1 is 0, 1. b2 is now the imaginary part. Here it's just 2. Here it's just 7, right? Finally, let's do one more example and move on to the other topic. b1 here is, real part is 1. Real part on the second row is nothing, right? 0. b2, imaginary part here is -3. Here 4. Okay, so that is how you find b1 and b2. Okay, now next thing we want to do is we want to look at eigenvalues. Now we know our eigenvalues are complex numbers. So one more important thing, one more topic that comes with complex analysis is complex conjugate. Now what is complex conjugate means? Let's say you have a complex number alpha plus beta I. Its complex conjugate means, so you look at this operation here in the middle, it's addition. So the complex conjugate is alpha minus beta I. So you take the opposite sign. Okay. And if you have a complex number as alpha minus beta I, what is its complex conjugate? Alpha plus beta I. So complex conjugate is like a mate for the complex number that you have given, but you switch the sign in the middle, the operation in the middle. Okay, so here I'm not diving deep into the idea of complex conjugate. We just need it just to understand a simple thing in our lesson. Okay, all right. So here what is the complex conjugate for 2 plus 3i? 2 minus 3i. Okay, now what is alpha here? Alpha is 2, the real part. Beta here is, no matter what complex number you took, beta is 3. Okay, here beta is actually 3. Beta is always positive. So that is the difference between beta and b2. For b2 we include the sign that inherited in the complex number, but for beta it's always positive. Okay, so here the complex conjugate is 4 plus 5i, right? The opposite sign. Here the complex conjugate is, now here you have plus, okay? So it's -2i. Okay, here the complex conjugate for 1 plus 7i is 1 minus 7i. Okay, so two very easy concepts. Okay, but why do we need them? Well, you can learn them in the future videos. Okay, all right, thanks.